So this is the GCSE Chemistry OCR 21st Century High Tier paper, and we're looking at question 7. Okay, question 7. Drinking cups can be made from polypropylene or aluminium. Polypropylene is made from propene. The displayed formula for propene is shown below. What is the empirical formula of propene? So the empirical formula is the simplest whole number ratio of the different atoms. So displayed formula is what you see here. It shows all the atoms with all the bonds. So in here we've got carbon and hydrogen. The ratio of carbon to hydrogen, we just need to see their number. So we've got 3 carbons and 6 hydrogen atoms. Okay, this is the ratio of carbon to hydrogen, but the empirical formula is the simplest whole number ratio. We can simplify this ratio further, so 1 to 3. So the ratio of carbon to hydrogen is CH3. Okay, C1, but we don't put a 1 there. So that's the empirical formula. Part II, draw the structure of a repeating unit of polypropene. So polypropene is basically lots of these propene molecules linked together. Okay, it's a polymer of propene. What we can do is draw the structure of propene again in a more simpler way so that it's easy for you to visualize how we would do the repeating unit. I've literally drawn the same thing again but in a different way. So we've got carbon-carbon double bond just like here. This carbon is bonded to 2 hydrogen atoms here, and this carbon is bonded to 1 hydrogen atom here and another CH3 group. So I've put all of this CH3, C bonded to 3 hydrogen atoms here. Okay, so this is exactly the same thing. I haven't changed the actual structure of it. I've just put it in a different way so that it makes it easier for you to visualize. So now to do this repeating unit, you just draw this propene molecule but without the double bond. So it's not carbon-carbon double bond, it's a single bond. That's the key thing that changes when you draw the repeating unit, and you get 1 mark for doing that. Even if you get the rest of the structure wrong, if you don't include the double bond, you get 1 mark for that. Okay, so this is your repeating unit, and obviously we have these bonds at either end of the repeating unit already drawn for you, and n just shows it can be repeated to whatever number of times. Now you could have done CH3, so instead of writing CH3 you could have drawn all the bonds here. That would have been fine, and the mark scheme also says you could have had this CH3 group anywhere around this molecule. Part B, aluminium melts at 660 degrees Celsius, polypropylene melts at 130 degrees Celsius. Hot water from a kettle has a temperature of between 90 degrees Celsius and 100 degrees Celsius. James says aluminium drinking cups are better than polypropylene cups. They are less likely to go soft when hot water is added from a kettle. Do you agree with James? Yes or no? Explain your answer. So we don't agree with James because if you think about the question, it says hot water has this temperature, okay, 90, 100. Both aluminium and polypropylene have melting points that are way above this temperature. Okay, so if water is in either of those, it won't melt. So it's not that one is better than the other. Okay, so you can just say hot water is at a lower temperature than both aluminium and polypropylene. And the last part, which statements about polymers are true and which are false? Tick 1 box in each row. So the first one, when monomers form condensation polymers, a small molecule is also formed. So that is true. In condensation polymerization, normally when the monomers come together, there's a small molecule formed, and most of the time that's water, H2O. DNA is a polymer formed from nucleotides. That's also true. So the nucleotides are the monomers, and they come and link together. Lots of nucleotides in a chain form a polymer, which is DNA. And the last part, to make a condensation polymer, each monomer needs only 1 functional group, and that is false. Okay, in condensation polymerization, you need 2 functional groups. Okay, so that the monomer can bond with 2 other monomers, 1 at each end.